Welcome to qnawire.
Okay, as far as I can tell, something went very wrong with the transcribing of this problem, and it's really choppy. But I think what we're supposed to do is, when given the element, we have to give the atomic mass. We have to give the number of protons, the number of neutrons, the number of electrons, um, and I think that's it. And what we've been given is silicon, but I can't actually see what number is up there, and cobalt, right? So let me try to figure out what might be there, what is likely to be there, at least. Um, so silicon 14. There's just like a bunch of numbers. And cobalt. Uh, so the most common isotope of silicon is silicon 28. Okay, so maybe, hopefully, that would correspond to something that they would have put up there. Um, right, and as silicon is silicon 14, maybe this is what was up there. Given that, what would be the atomic mass unit? Well, the mass is always given right up there, right? So the mass should be 28 in this case. The number of protons is always given right there, right? So this should be 14. The number of neutrons should be the mass minus the number of protons, right? So this would also be 14 in this case. And then, supposing that it is a neutral molecule, that it doesn't have some charge up there, the number of electrons should be equal to the number of protons. So not too bad. Let's look at now cobalt. Cobalt's most common isotope is, or the only stable isotope is cobalt 59. Okay. So the atomic mass units, again, just given right up there, that's 59. And the number of protons, again, given right there, 27. Number of protons is the same as the atomic number, right? The number of protons is what defines an element. All silicon has 14 protons. If it had 15 or 13, it would no longer be silicon. Just thought I'd point that out. Number of neutrons, again, is going to be the atomic mass minus the number of protons. In this case, that's 32. And the number of electrons, assuming this is neutral and doesn't have some sort of charge up here, should simply be the number of protons